This next section uses systems of equations with word problems, and the hardest part about this is getting the equations written correctly. One thing that I strongly suggest is identifying your variables at the very beginning, and the way that you'll identify them is by looking at the question. How much does each pen and each pencil cost? So what I'm looking for is the cost of a pen and the cost of a pencil. So I might say I'm going to let X equal the cost of a pen, and I'm going to let Y equal the cost of a pencil. Now, I have 8 pens. That's 8X. I have 7 pencils, so that's 7Y. And I'm told that it's $3.37. Then I've got 5 pens, and I've got 11 pencils, and that costs $3.10. Now I can solve this, and you can use any method you'd like. Based on the setup of this equation, I think that solving by elimination is probably the best option. I notice that if I just add these together, nothing eliminates. So I will multiply this first equation by 5. I will multiply the second equation by -8 because I want to eliminate the x's. I need one of them to be positive and one of them to be negative. So my top equation becomes and then the second equation when I add them together, 40x and -40x eliminate. 35 minus 88 gives me -53y. And then 16.85 minus 24.8 give me -7.95. When I divide, I find that y is equal to 0.15. Of course, I'm not done. I need to find the value of x. So now I have to relate this back to the problem. X is the cost of a pen. Y is the cost of a pencil. So a pen costs 29 cents and a pencil costs 15 cents. For the next problem, when I start to identify my variables, I'm going to first look at my question. How many colored marbles does Lauren have? So I'm looking for the amount of marbles. So I will let x equal the number of plain, and I will let y equal the number of colored. She says, or we know, there are 32 more plain than colored. So if I have to think about this, if I have 5 colored marbles, how many plain marbles would I have? Well, 5 plus 32. So I can say that x is equal to y plus 32. Okay, the number of plain marbles is equal to the number of colored and 32 more. The next part says that there are 180 total. Well, so if I take the number of plain plus the number of colored, I will have 180. This problem lends itself very nicely to substitution. I can plug in all of this in place of x. So according to this problem, y, the number of colored marbles, is 74. That is exactly the question I was asked. I do not have to go any farther. This last problem is one that's very challenging, so I'm again going to direct you, once you have read the question, once you've read the whole problem, go to the question. How many of each size gift basket should you make? This tells us that my variables need to be the number of small gift baskets and the number of large gift baskets. Now that I have this, my two equations are going to represent what I have information on. I have 58 pounds of chocolate total and 36 jars of nuts total. That means that my first equation is going to be the amount of chocolate used per basket to use up all my chocolate. Well, it says here that the small basket uses 3 pounds of chocolate, so that's 3x. The large basket uses 4 pounds of chocolate, so that's 4y. And altogether, I have 58 pounds of chocolate. Now I will write an equation to represent the jars of nuts that we have. The small basket uses one jar. The large basket uses 3 jars. And altogether, I have 36 jars. Now that I've got this information, I can solve the equation, or solve the system. I see here I've got two equations in standard form. For this, I will again use elimination. I will multiply this bottom equation by -3, because then I can eliminate the x's. My new system becomes 3x 4y equals 58, -3x minus 9y is -108. When I combine these, my x's cancel. So now I see that I need 10 large gift baskets, and then I can plug this in to find out the number of small gift baskets. So they should make 6 small baskets and 10 large.